Right? Cathode are called emitter, which is made of photosensitive metal, usually negatively potential. Okay, can read yourself. As I said, no point in teaching it. Uh, how does current depend on intensity? Right? Greater intensity, more electron emitted. So you can expect the current, right, which is the number of electrons emitted per second, to be a straight line passing through origin. No? What does it mean if k equals to 1? Yep. What does it mean k equals to 1? Any idea?
Um,
Remember
constant.
what do you mean by constant? Physically, what does it mean? You have photons being
Direct.
sent into the metal surface, electrons emitted. So what does k mean?
Like everything is directly proportional.
That means it's electron. Each photon means an electron. That's why it's k equals to 1.
Ah,
Okay?
yeah.
Each photon means an electron and cause emission. Why is k less than unity? Explain. Why is k less than 1?
Why? Not
Ah,
like
not all photons meet electrons. Okay?
oh
So if it's 1, means every photon you send in meets an electron. And both photon and electron are very small. So sometimes the photon may not meet an electron, will just pass through the metal. That's why k is less than 1. Right? Useless is for info only. Right? That's your incident photon. Right? That's your light photon. That's your photocathode. It causes emission of electron. Then electrons hit the diode. You produce more electrons, so you multiply. Okay? So in a photomultiplier tube, a single incident photon produces a pulse of current through an external circuit. The tube can be used to obtain picture in extreme low light condition level. Right? This is can see in some houses there. Right? Infrared in security device to determine when an invisible ray of light has been broken. Right? About 10 more minutes. Simple application of photoelectric effect. Garage door sensor consists of a sending unit, infrared beam, infrared as a receiving or detector, and the receiving unit, phototube, which produce a photoelectric current in the receiving unit. When you interrupt it, no current will flow. Interrupt the current, causing a circuit to activate the motor, pulling the door open. Right? That's how you open the door for the person to enter, or intruder coming in. It cut off the infrared, tell the occupant of the house on your CCTV that there is an intruder. Okay, summarize for you. Right? What is photoelectric emission? Emission of electron from metal surface when illuminated by electromagnetic radiation of certain energy or certain frequency. Right? Photoelectric emission, evidence of particulate nature of electromagnetic radiation. Right? Electromagnetic radiation have what we call intensity, frequency, and number of photons emitted per second. Right? These are observations. Summarize for you. Right? 4 or 5 of them. F naught is threshold frequency. Is the minimum frequency of electromagnetic radiation to produce emission with electron emitted with zero velocity. And then the electron emitted, number of electron is measured as a current. Right? Measured as a current. Right? There's a photocell. There's a potential difference across a photocell. So we can measure the maximum kinetic energy of the electron. And this is the graph. Work function, threshold frequency, straight line equation. And then E equals to HF. We modify the power to NP E over T. Right? E is given by HF. And Einstein photoelectric equation. Right? Work function, minimum energy of photon or minimum energy that causes electron to be emission of electron from the surface of metal with zero kinetic energy. Okay, any question to ask? Anything to comment?
All right.
If not, let's try to do some question. You should try to do the other question. Right? Page 238, you can try the question.
2, 3.
Okay, let's do exercise 22.1. The others you can just a review of what you have to learn. Okay, have you got the page? Page
Yes.
238. Page 238.
Got it.
Okay, self-test you can do yourself. Try this one. Monochromatic source of wavelength. Sorry, I don't think you see that. Okay, page 238. Why am I start making mistake? Okay, monochromatic source of wavelength. That one emits energy at a rate of 60 watt. What part of the electromagnetic radiation is this wavelength? Yep. Yep.
Infrared.
This wavelength, what part of the electromagnetic spectrum is this one?
Is it like infrared?
No, shorter than visible light. So it's ultraviolet. Always remember, visible light is about 0.4 to 0.8 micrometer. Right? And this is a shorter wavelength than visible light. So it's usually ultraviolet. Sorry. Oh, sorry, I'm the one making the mistake. It's longer wavelength. This is longer wavelength. So it's infrared. Right? It's on this side, not on that side. Right? On this side. Of the longer than this one. Okay, what's the frequency of radiation? You should be able to calculate. This is just to reinforce what we have learned, all the formulas that we have used. Yep. What is the frequency of radiation? Yeah, given wavelength. Speed of light can be obtained from the formula sheet. Use that formula.
6.25 times 10 to the power 13.
10 to the power 13 hertz. Okay, that's why we calculated. Energy of photon, E equals hf. Right? E equals hf. Right? Frequency we have just calculated. Number of photons emitted per second. Yep, that one you have to use 60 watt. Can get the answer.
1.45 times 10. Oh,
Right?
21.
Just use this formula. Power is N E over T. E is energy that we have calculated. Right? This number of photon N, right? And T is rate of photons falling on the metal surface. Right? 60 watt, P 60 watt. This one we have calculated. Okay, good. You got the answer. When sodium electrode is used in photocell, I think we won't bother about this stopping potential. In tissue about stopping potential, basically you use EVS to calculate that. Don't bother about that. Okay, let's try the next one. Number 3. Experiments are conducted to investigate photoelectric effect. It is found that on exposure to metal surface to light, either electrons are emitted immediately or they are not emitted at all. Suggest why this observation does not support the wave theory of light. Yep. For wave
Because there
theory,
are.
electron can collect energy continuously. Electron will be emitted at all frequencies after sufficient long delay, but we find this not true. Okay. Without any calculation, suggests why no value is given for EK for radiation of wavelength. This one. For this wavelength, why is there no value given?
Hmm.
Wavelength is longer than the threshold wavelength, no? So no emission, no?
Oh, okay.
Use your data to determine the work function. Yep.